Hey everyone, welcome to my channel. In this video, we will learn pose estimation. We will detect 33 different landmarks within a human body, and all of this will be done in real time. That's right, more than 24 frames per second and only running CPU. We will first look into the basic code required, and then we will create a module out of this so that we don't have to write the code again and again. And yes, we will be creating a lot of projects with this, so don't forget to subscribe and hit that like button. If you like to create real-world computer vision apps, do check out my premium course in which we learn how to create apps such as object detection, augmented reality, document scanner, and many more. The link will be in the description below. So, without further ado, let's get started. So here we are in our Pycharm project, and you can see that we have named it Pose Estimation Project, and we have a folder here with pose videos. So if I open this up, you can see that we have a lot of different types of videos. We have a total of 9 videos. So let me play a few. So here you can see this one is a little bit smaller, and some of these videos are actually slow motion. So when we are running it, it will look like it's slow, but it's not actually slow, it's actually slow motion. So like this video, and then I think, what else? I think this video as well, it's slow motion. And I think this one is fine. Yeah, this one is normal. This one is slow-mo as well. So I took these videos, I think from pexels.com. So we are going to test these videos out and see how well does our pose estimation work. So we will select all of this, or let's create a new file. Let's delete this one. So let's delete this, and now we are going to create a new file, and we will write here pose estimation minimum. So this is the bare minimum code that is required to run it, and later on we are going to see how we can create a module out of this so that we don't have to write the code again and again for a lot of different projects. So let's start by importing CV2 and then importing media pipe as MP. But now you can see that we get an error. This is because we did not include these packages in our project. So how can we include those? So we will go to File, Settings, and we will go to our project interpreter and open that up. And here we will write OpenCV-Python, and we will hit install. And then we will write media pipe and we will hit install. So now both the packages have been installed, and we can go back and you can see the error is now gone. So OpenCV is the library that we will be using for image processing, and media pipe is the framework that will allow us to get our pose estimation. So now the first thing we will do, we will read our video. So we will write here cap is equals to cv2.video capture, and we will simply give in our video number. So here we will write pose videos, and we will write video number 1.mp4. I think the one is quite big. Let's try it out, and later we can change it if we want. And then we will write while true, and we will write success, and image is equals to cap.read. So that will give it our image, and then we can write here cv2.imshow, and we will write here image, and then we will write here image, and then we will write cv2.wait key, and we will write 1 so that we give a 1 millisecond delay. Okay, so let's run this and see if it works. And there we have it. So our video went quite fast. So the frame rate is actually quite high at this point. What we can do is we can check the frame rate by writing here time. Let's say current time is equals to, we need to import time as well. So we will write here import time, and then we will write time dot time. Then we will write that our FPS is equals to 1 divided by our current time minus our previous time. And our previous time is equals to current time. And we need to define the previous time up here at the top. So we will write here previous time is equals to 0. And then we can simply put our text. So we will write here put cv2 dot put text, and we will write in our image, and then we will write in the text itself. So we will write string FPS, but we will convert it into an integer before we do that. Then after that we have our origin, so let's say 70 and 50, and let's say the cv2 dot font plain, and let's say 3, and then for the color we can put 255 0 and 25 and 0, and then we can put 3. So this should give us our frame rate. Let's try that out. Wait, what happened? Okay, this should be below over here, my bad. So let's run it again, and there we have it. So you can see it's 100 something frames per second, so that's quite a lot. If we want to reduce it, we can put here, let's say 10. So now it's like 50, 60 frames per second. But when we are using our model, it will automatically slow it down, so we don't need to worry about that. So the next step would be to create our model, so our object, so that we can detect our pose. So here we are going to write mp pose. Pose is equals to mp.solutions dot pose. So we are going to use this, and then we are going to create our object. We are going to say pose is equals to mp pose dot pose, and then we will give in our parameters. So if we go to the parameters, you can see that we have the static image mode. This is basically that when you are detecting and when you are tracking. So if you put it as true, then it will always detect based on the model. It will always try to find the new detections. But when you put it as false, it will try to detect, and when the confidence is high, it will keep tracking. So there will be a tracking confidence, and then there will be a detection confidence. So whenever it detects, if the confidence is more than 0.5, it will say, okay, now we have detected, now I will go to tracking. Now the tracking will check. If the tracking confidence is more than 0.5, it will keep tracking. Whenever it goes below 0.5, then it will come back to detection. So this way we do not use the heavy model again and again for detection. Instead, we use detection, then tracking, then whenever it's lost, we use the detection again. So this is what this does. And then we have the upper body only. So you can decide if you want to detect only the upper part. So it will have, you can see here, we have 33 poses, landmarks, or only 25. So it's up to you which one do you want to use. And here we also have a feature to smooth, which is by default true. So we will keep it as true. So we can define all of these parameters, or we can skip them. It's up to us. So for the initial purposes, we are going to skip all of these for the simplicity. So then we are going to go down here, and simply we are going to convert our image. So we will say image RGB is equals to cv2.cvt color. So this image is in BGR, but this library or this framework uses RGB. So to make it compatible, we have to convert it. So we will write here image, and then we will write cv2 dot what color, underscore BGR to RGB. So this is our conversion, and once we have done the conversion, we are simply going to send this image to our model. So we will write here results is equals to pose dot process, and we will write image RGB. So that's pretty much it. So that will give us our detection of our pose, but it will not draw anything. But for now, we can just run it to see if everything is working. And now you can see that the frame rate has decreased. So this is good to see that our model is actually working. But you can see that it's almost real time. So that is really good. So now what we can do is we can draw our landmarks. So whatever we have detected, we can draw it. But before we do that, we can print the results as well. So we can write here results, and let's see what do we get. So here you can see we get nothing. So it's just a class, but we don't see any information. So how do we see the information? We simply write results dot pose landmarks. Landmarks. So if we run that, now you will see that we are getting actual landmarks. So each landmark will have the X, Y, and Z value, and then it will also have a visibility value. So how visible is it? So this is the information that we get. So we can put all of this in a list later on so that it's easier to access. So then we will check if it is detected or not. So we will say that if this is present, if this is true, then we are going to write here that mp draw landmarks, draw underscore landmarks, and then we are going to define our parameters. But here you can see we don't have anything called mp draw. So we are going to declare that. We will write here mp draw is equals to mp dot solutions dot draw utilities. So we will use that, and then we can write here within our landmarks, we can send in our image. Then we can write results dot pose landmarks. So this is the same thing that we are printing out that we got. So we will write here landmarks, and then what do we have? I think that is good. Let's do that. Let's run it. And there you go. So now you can see we are getting all the points. You can see that it is in red. Now what we can do is we can also add the connections or the lines between these. So here we can write mp dot not mp pose dot pose connections. So that will fill up the connections. There you go. So now you can see we have the green lines, which are the connections, and then we have the points as well, and we are detecting them all at real time. So that is very, very amazing. So now we know that we are getting this information, but how can we know which is for which? So here it just says landmark this, landmark this. There is no indication of which landmark represents what. So what we need to do is we need to organize a little bit so that it is in a list and we can simply use these values in our project. So for example, I will say I want landmark number 5. I want landmark number 3. So if we go to the MediaPipe website, you can see here that these are the landmarks that they have given. So for example, if I want the right ear, so I can just say I want the element number 5, element number 8. So give me that element. If I want the nose, I can say give me the element number 0. So based on this, it will become very easy for us to actually create our new projects. So gesture recognition and lots of different applications will become very, very easy. So how can we extract the information within this object? So what we can do is we can write here for ID and landmark in enumerate, we will write this result. So we are going to loop through this, and we want the count as well. That's why we have written enumerate. So it will give us the loop count over here. So 0, 1, 2, 3, and so on. Then we are going to get the shape. Actually, this will be, we have to add here landmark. And then we are going to write here height, width, and channel is equals to img dot shape. And the reason we need this shape is because, let me actually show you why and you will understand. So what we can do is we can write here print, and we can write lm dot x, or let's just print lm so you can see what is happening. And we can print the ID number as well, so you know what exactly are we extracting here. So let's run this. So there you go. So now you can see we have the ID number, and this is the information of the landmarks. So 30 is this, 21 is this, and it goes all the way to, wait, why is this showing? I think I didn't remove the other print. Anyways, so you can see here from 0 to 32, we will have all these 33 landmarks. So let's go down and let's just remove the previous print first. Okay, so now we know that we have the ID and we have the landmark, but you can see the landmarks, they are actually in decimal places. So this is basically a ratio of the image. So what we can do is to get the actual pixel value, we can say that lm.x, this will give us this x value multiplied by the width of the image. So that will give us the x of our, what do you call, the point or the landmark. So it will give us the exact pixel value. The same thing we can do for lm.y, and we can multiply it with the height. So we can do that. And then what we can do is we can put them in our cx and cy variables. So this way it will be easy for us to use. The indentation is wrong. That is why it's giving an error. Okay, so also we need to convert this into integer because we have to make sure it's not a float or a double, because we are talking about pixel values. So then what we can do is to confirm that this is happening and we are getting the correct values, we can simply print the circle on top of this point. So we can write here cv2.circle, and in the circle we will write image, and then we will write cx and cy, and then we can write, let's say, the value of 15. 15 will be too big. Let's say 10, then 255, 0, 255. This is purple. Let's make it blue. And then we will write cv2.filled. So this will overlay on the previous points if we are detecting it properly. So let's try it out. So there you go. So now you can see we have those blue dots, and these are the ones that we put ourselves. So this means that we are getting the correct information at the correct pixel values, and it is working good. We can reduce this to 5. There you go. Much better. Actually, let's try another video. We have been using the same video. We have like 9 videos. So let's try a random one, number 5. Yeah, that looks good. Let's try number 6. Yep, that is good. Number 3. There you go. Okay, here we had an issue, but now it's fine. That's good. So we can see that we are getting good results, and that should be good enough for us. So next what we can do is we can convert this into a module so that we can use these values very easily. So the first thing we will do, we will go here and right click, and we will create our module. Let's call it pose module. And we will copy all of the bare minimum code and we will paste it here. So that looks good. Now the first thing to make it a module, we have to write here if underscore underscore name is equals to underscore underscore main, then we are going to write main. So what this does is that if we are running this by itself, then it will run the main function. And if we are just calling another function, it will not run this part. So this is what it means. So we will write here main, and within the main, we are going to write everything, or we will write the dummy code in the main. So whenever you want to see what a module is capable of, or the testing script, you can put it in the main function. So here we will take this till here. We will cancel it from here. We will cut it and we will paste it in the main. Then we will take all of this as well. We will cut it and paste it in the main again. So that should be good. And what else? So now we are going to create a class. So in that class, what we should be able to do is we should be able to create objects, and we should be able to have methods that will allow us to detect the pose and find all these points for us. Okay, so here we are going to say that our class, let's say, is pose detector, and inside that we will have our first method, which is the init. This is the initialization. So we will write here init self, and then we are going to write in the parameters that are required. So whatever parameters we are expecting, we will write here. So here we are going to write mode. So if I go to, where is it? Okay, let's go to pose estimation, and here we are going to go to pose. So I will copy all these parameters and we will just paste them here and we will write. So the first one is mode. So we will keep it as false so that we get fast detections. Fast detection plus tracking. And then we will write here upper body. So upper body is equals to false. And then we have the smoothness. Smooth is equals to true. And then we have the detection confidence is equals to 0.5. And then we have the tracking confidence is equals to 0.5. So these will be our initial parameters. And then we can remove this. And then we can write here that self.mode is equals to mode. Now, if you're not familiar with object-oriented programming, then this basically means that whenever we create a new object, it will have its own variables. So this, whenever you write self.something, it is the variable of that object. So whenever we are using a variable within our class, we will write self.something. So self.objects, self.mode, self.upbody. So we are going to write that. So here we are saying that the specific variable of our class or our object is basically the one that the user has provided. So it will set this instance of that object to false. So this is what it does. So here we will copy all of these and we will write up body is equals to up body, and then we will write smooth is equals to smooth, and then we will write detection confidence is equals to detection confidence, and we will write track confidence is equals to track confidence. So as I mentioned before, we just have to put self dot in front of each one of these and that should be good to go. So next we also have to declare these. So again, this will be part of that object. So we need to write self. So here we will write self.draw, self.impose, and self.pose. and we will write here self.mpose. So this is good. And what we can do is, earlier we were not using any of these parameters, but now we have to. So here we are going to send in all the parameters. So we will write here self.mode. So self.body, self.smooth, self.detection confidence, and self.tracking confidence. So that is pretty much it. Okay, we need to put a comma here. And yeah, so our initialization is pretty much done. And now what we can do is we can create a method to find the pose. So we can write here find pose. And we do have to write self here. So whenever we are creating a new method, we have to write self first. And then we have to give in our image. And then we will also have a flag called draw. And we will put it as true. So this basically what it will do is it will ask the user, do you want to draw or not? Do you want to display it on the image or not? So we want to display. So we are going to put this inside here. And then this draw, if results draw this. Yeah, this will be separate. This for loop will be separate, and this results will be here. So let's push this in, and we can remove this. And what else? So now we need to write the self dot. So here we will write self dot pose process and self dot mp draw. Then we can also write self dot mp pose. So anything missing? No, it seems fine. Now what we need to do is we need to put that flag. So we will write here if draw, then we basically do this. So that should be good. So let's try it out. Or should we put it inside? Let's put it inside that. So we will say that if landmarks are present, or let's put the draw inside. So if the landmarks are detected and we said draw, then you need to draw. So that is good. So by now we should have a working class. So we can create an object from it and then we can run it. So let's try that out. So here we will write our detector. Detector is equals to our pose detector, and we will give in the default parameters. And here, what is happening here? This should be inside the while loop. So here we are going to write detector dot find. What was it? Find or detect? Find pose. Find pose. Why is it not detecting? Oh, the indentation is wrong. So now it will detect. Okay. So detector dot find pose, and then we have to give in our image. So that should be it. And we need to return the image. So we will write here return image, and we can bring in the image back here. So if we run this, it should draw on our video. So let's run the pose module, and there you go. So now it is running and it looks good. Let's try it on the first image. There you go. So this is quite good. And what we can do next is we can do the main part, which is to find the points. So we need to get those points. here we are going to define the get position, and we will write inside that we want an image, and then again we want the draw flag. So by default we are going to, yeah, let's put it as true, and then we can uncomment this. Okay, so now what we will do is we will, first of all, here we are getting an error for result because we need to write self.results here and here and here and here. Okay, so that should be good. And what else? So we need to push this in the for loop. So now we are just looping. We need to check first as well if the results are available. So if the results are available, then we will use this for loop, and then we need to put it in a list. So we are going to write a list, lm list, which is for our landmarks, and we will append our values. So here it depends on you, what kind of values do you want to append. So I'm going to append only the X and Y values and the ID. If you want to append the Z and the, what was the other one? The visibility, you can do that too. So here I will write lm list dot append, and I will write in the ID. So here I will write ID, and then I will write the CX and the CY. And I will add the option here that if draw, then do this. So this looks pretty good. So let's go down and try it out. So where is it? Here. So we can write here that our lm list is equals to detector dot find position. Is it find position or get position? Let's keep it find position, so it's similar to the previous one. Find position, and then we will give in our image, and let's keep it as true for drawing so we know it is detecting. And we can print out the list as well. So we can print out lm list, and there you go. So now you can see we are, wait, why is it printing this? That is not right. Okay, this is printing this parts. Any other prints? No. So let's run it again. Yeah, so right now it's none. Wait, why is it none? The lm list is none. Lm list, oh, we didn't return it. Forgot to return lm list. Okay, so now we can run it, and there you go. So now we have the list, and if we go till the end, you will see we have a total of 32 points. So we have 33 points because we are starting from 0. So now I can easily say, for example, I want number 0, I want number 8, I want number 5, number 23, whatever I want, I can write down here. So let's say we want number 8, or let's say we want number 14. Let's try that. Number 14. And there we have it. So this is the number 14. And if I wanted to, I could draw this number 14. So I can put this as draw false, and then here I can write lm14 at 1 and 2. So this will be 1 and this will be 2. And I can make this really big so I can see what exactly am I tracking, and I can change the color of it so that it is a little bit different than all of these. So I can put it as red. And there you go. So now you can see we are tracking this elbow. So this is how easy it can be. By the way, whenever it finishes the video, it will give you an error. You can loop through that. There's a function for that as well, but we're not going to do that. So this is the basic idea of how you can convert this into a module. And now you can use this in any project that you want, and you can easily find the position. So how exactly can you do that? So let's create a new file, and we will call this our awesome pose project. So we will copy the parts from the main. So as I said, this is the testing code. So we will copy all of that and we will paste it in our awesome project. And now we have to import. So we will write here import CV2, and then we have to import time, and then we have to import our module. So our module needs to be in the same folder. If it's not in the same folder, it will not work. So you have to write import pose module as PM, because it's a smaller name. So we can write here PM dot pose detector. So this will create the detector, and everything else will run the same way. So if we run this now, our awesome project, and you can see it runs exactly the same way. So now I can use this in many different applications. So one thing we can do is we can test some other videos. So let's say number 2. There you go. Again, we are detecting the right elbow, and you can see it's tracking really well. That's pretty awesome. Even when it's a little bit hidden, it's still tracking it. That's really good. And then let's try number 3. What happened to number 3? There's an error. List index out of range. Okay, so yeah, this is a problem because we are not checking if actually the list is filled or not. So we need to check if lm list is not equals to 0. Actually, the length of it is not equals to 0. If the length of this is not equals to 0, then only we can do these two things. So actually we should change that at the main module as well. So where is it? Here. So let's run the awesome project again, and this time it works. So probably the first frame it was not able to detect. That's why it was giving this error. So now you can see it's detecting that elbow. Let's try number 4. There you go. Detecting the right elbow very nicely. Let's try number 5. There we have it. Excellent. The frame rate is amazing. So you're getting real time. Number 6. Pretty good. And the best part is it's running on CPU. It's not actually using GPU to run this. So that is very good. Then we have number 8. Let's try that. Okay, that looks good. And then we have number 9. So yeah, that is pretty good. So there are a few instances where it gets it wrong, but overall you can see it's really good. So this is basically how you can detect pose in an image or in a video, and you can do the same thing on a webcam. I'm not doing this on a webcam because it will be very hard for me to test that again and again. I will have to stand up and go back and be in the frame to get it up and running. So that's why I'm using these videos. So you can see that it is fairly good. And all you have to do now is use this pose module, and all these files will be available. All of these 3 files, the minimum code, the module, and the awesome project. All of these will be available on my website. And a lot of you ask me, how do you access the code? The code is showing gray text. It's not available. Well, you just have to log in and you have to register on the website, and then you can pretty much access most of the codes by just enrolling in the course. So most of my courses, I think 95% of my courses are free. So you can just log in and click on enroll, and then you can run it. So this is it for today's video. I hope you have learned something new. I hope you can use this in your amazing projects, and I would love to see some of your projects, what you come up with. If you do make a few of these projects, do tag me on Facebook or Instagram. I will love to see them. And if you liked the video, give it a thumbs up. If you really loved it, share the video with your friends. And if you haven't subscribed yet, do subscribe, and I will see you in the next one.